All right, folks, welcome back to the IP Showcase Theater. My name is Thomas Edwards. I'm a Senior Manager of Solutions Architecture at Amazon Web Services, specializing in media and entertainment. Been in the broadcast industry for about almost 25 years now. Have seen some exciting things like SMPTE 2110 come along, and I'm excited to share a new specification with you called VSF, and that's the Video Services Forum TR-12, which is an open approach to device discovery and control. So our customers have been giving us feedback on some of the challenges that they've had installing things like encoders and decoders on site. So we've got one customer said we can spin up an entire live cloud production in 15 minutes, but it took us 3 days to figure out how to connect the camera sources. Another one said we need an alternative to satellite distribution where we can manage distribution to affiliates without requiring them to learn how to use the cloud. Because, of course, getting knowledgeable talent is often challenging and expensive. My local stations can barely manage their SDI infrastructure. We need an easy way to connect them to the cloud where we can manage master control remotely. So we took some of this feedback that we've been getting from customers, and we call this the first mile, last mile problem. Connecting ground devices requires almost two people to manually communicate and configure both sides of the link. Raise your hand if you've installed a remote encoder somewhere. No? Yeah, we've got one. Okay. Well, you know what you need to do. You need to type out, IP address, right? Subnet, router. The firewall. I need to go talk to the firewall person and get the firewall ports plugged in. This, that. And then you also need to configure that encoder, right? The data rate on the encoder, maybe the codec, GOP size, things like that. The video format, whether it's 1080i or whether it's 720p or 1080p. So the staff has to be skilled in video and networking with advanced troubleshooting skills, because it could be a problem with the video interface, could be a problem with the network interface. And this is really time consuming for the customers we see, and it needs to be repeated often for events, right? If you have an NFL event that's coming up, you're going into the stadium, setting it up, then the event's over, you pull it out, and you go to another event, so it's very challenging to be able to remotely monitor and control these ground systems. So there have been some proprietary solutions suggested, and one of them actually came from Amazon Web Services, the link encoder, which you just plug into the wall. It calls back. It gets all the information it needs. It's discovered, it's configured, what have you, which is simple and easy. But we recognize that there are real limitations with proprietary formats. You've got a limited encode feature set. There are limited form factors. It's only what that vendor is providing. It's often limited to a single function like encode, but we also need to remotely control decoders and cameras and other functions. And it really was purpose-built for one vendor, so that doesn't really do much good. So we approached the Video Services Forum with the idea of a project for a client device discovery common specification, and this has become Technical Recommendation 12, or TR-12, from the VSF. So this is a VSF initiative for the discovery, configuration, and control and monitoring of arbitrary ground devices, not just necessarily encoders, but encoders, decoders, up-down cross converters, you name it. It's an open source SDK, so it can be easily integrated into any device alongside common transport libraries you might be using like RIST or SRT. So it doesn't replace those, but it's really the way that you can initiate the communication with those edge devices and be able to properly configure them without too much hassle. And the device pairs with the cloud service over HTTP and then establishes a secure MQTT connection, which provides real-time methods for common connection management functions, right? You could set your protocol, bit rate, encoder parameters, And it includes extensible schema, allowing control of arbitrary functionality within that device. So if you have some special kind of capabilities within the device, you can add these extensions onto the TR-12 schema. So we'll go into some details about VSF TR-12. So we've tried to start by understanding what are the real requirements of the stakeholders, right? For the end users, they want something that works with their existing fleet, that is compatible with the existing control plane, something that's non-proprietary, something that any vendor or customer can use. From the device manufacturers, they want something that was easy to implement. They want it to be compatible across a wide range of device architectures. They want to be able to expose these unique settings that they have. Some of them have special things which you want to configure, and also then make it non-proprietary as well, because they don't want to be locked down to, let's say, a single cloud or what have you. And for service providers, they wanted a modern API definition, which their developers can utilize. They want to be able to generate user interfaces. They want to have a cloud-side payload validation and have a fairly zero marginal effort to onboard new device types. They don't want to have to rewrite the cookbook every single time a new device comes along. So what can you do with VSF TR-12? You can configure the device. You can set up all of its key parameters, its capabilities, and you can also do this using infrastructure as code. So instead of having a human being coming in there and having to twist a knob, type something on a front panel, it can be code that's also highly replicable, and you can, with one piece of code, be able to configure hundreds of devices. We also like some real-time control, because there are some things that need to happen, like I can imagine on IRD, if you want to switch between satellite carriers, if suddenly your 720p signal isn't coming in, you have a 1080i signal, you need to switch to that. And also provide other runtime operations in real time. We like to do remote monitoring, so know exactly what's going on with that particular device. Is the video flow there? Is the SRT work? Is SRT experiencing a high number of retransmits? And to be able to display thumbnail previews of the videos coming into an encoder. And administrative functions, we want to be able to claim that device, to be able to authorize access to it, and then potentially to manage software updates on those devices once they're out in the field. So to securely register a TR-12 device, we're following kind of the best cryptographic practices in the industry. We initiate pairing by generating a public-private key pair, and from that, generating an X509 certificate signing request, or CSR. And that's used over HTTP to send a pairing request. So at your central location or cloud, you then generate a pairing code, generally a 6-digit pairing code for human beings. So that code comes back, is shared with the on-site folks, who then type in just a 6-digit code. Again, not setting up IP addresses, ports, video formats, just type in a 6-digit code for the auth request. And then via HTTP, it comes back to the service provider who claims the device. And then moving off of HTTP, going to MQTT, which is a more real-time transfer protocol, then you can generate an MQTT identity, send an X.509 certificate using the device-provided CSR, and then we can begin to perform MQTT URI and provide certs and all of the identity. And then the device is registered. So TR-12 uses two primary protocols. The first is it uses HTTPS, because that is generally something that gets through almost all firewalls. If there's a device inside your network calling out to the internet, almost everybody's got web browsers running on their desk. So going out, that works really well to come out do the pairing, and also potentially for large file uploads. Like, for instance, if you want to update the firmware on that device, then go out over HTTP and grab those large files to pull in. But for real-time control and monitoring, we probably want to use MQTT. So this is something that's got built-in access controls, encryption. It's bidirectional. It's low latency and low overhead. There are lots of APIs available for MQTT messaging, and also high availability endpoints can be hosted at scale with big cloud services. Many cloud services have highly scalable MQTT services which are available. So TR-12 uses a API model known as Smithy. Smithy can be converted to OpenAPI if you prefer that, but we are big fans of using Smithy. It's not an AWS thing alone. It's an open source model for APIs. Anyone can download it. Anyone can use it. We use Smithy to provide the pairing API, registration, configuration, and to also grab the status of the device. So again, this is something that your developers can take the Smithy API model, and very quickly they can generate all of the calls needed to pair, register, configure, and get status of the device. So you take that Smithy and you can automatically generate code. You can pull it out to something like Python or C++ very simply and be able to generate the backend that you need in order to register, control, and monitor the device which is out in the field. So TR-12 has two kinds of configurations. The first is what we're going to call simple settings. So this is something like a data rate for an encode or a video format, number of audio channels, kind of a single parameter at a time. But in talking with device manufacturers, we've also found that sometimes you need to gang together those settings so that, it's okay to have 1080 interlaced, but it's not okay to have 720 interlaced, right? So sometimes you need to gang together the functionality, and that's something we call complex profiles. So for the device, you might have, let's say, profile 1, profile 2, profile 3, and within those profiles, there are a large number of linked settings which are applied to the device. So, you might have a profile for a particular show or a profile for a particular video format or what have you. And everything's very flexible here. It's open source code. You can define whatever you need in terms of these different profiles. So if you want to get started with VSF TR-12, you can go to the VSF website, vsf.tv, and you can download the technical recommendation from the Video Services Forum. We also have software on GitHub, VSF-TV, again, hosted by the Video Services Forum. We do have a live demo of this going on in the West Hall. And also there's a talk from VSF VidTrans 2026, which happened in February, which you can watch on YouTube as well. In fact, lots of good talks at VSF VidTrans 2026. If you didn't make it out there, I highly recommend some of the talks from VidTrans. And that's all about TR-12. Again, it's not that complex a concept, but it is nice that we now have a common technical recommendation for this type of authorization, configuration, and monitoring for remote devices. Any questions before? No. Oh, one on. Okay, Monsieur.
Hi, Thomas. Thanks for the presentation. I realized I thought at the beginning TR-12 was really focusing on the discovery part over for the cloud and going through firewalls and this kind of challenge. But I realized it came to a more comprehensive set of discovery, control, configuration, and everything. So I need to ask the question of why have you not considered evolving NMOS, network media specific, open specification for this application? Because it seems that there's a lot of functionality in common?
Well, this was developed within the Video Services Forum. So I think that folks, I should say, I'm really just giving this speech. The developers here, really, Sydney Lovely and Brian Rundle of Amazon Web Services, were I think the lead folks on this. They wanted something that was fairly simple that they could, get out within, I think, a rapid period of time. And I think that they felt that the Video Services Forum, because traditionally, VSF has dealt with a lot of remote video transport issues, like RIST, for instance, IPMX, the TR-03, which became SMPTE 2110. So I think they felt that that was the appropriate organization to move this technical recommendation through. Now, should there be all these organizations like the Advanced Media Workflow Association, DSF, AIMS? I don't know. That's an interesting question, which I think industry should probably address. Other questions? No. Okay. Thank you very much.